Good evening. Today we are going to discuss about the case study on failure mode and effective analysis. Failure mode and effective analysis, that means short form FMEA. The main aim is to understand what is FMEA, why it is used and when can it be deployed. And also it is understand the definition, scoring system and the calculations which is used in the FMEA. And the next objective is to learn the steps to developing an FMEA and the pitfalls to avoid. FMEA. FMEA is a tool that allows you to prevent system, product and process problems before they occur. With the help of that, we can reduce the cost by identifying the system, product and process improvements early in the development stages itself. With the help of it, we can create more robust processes, and also it is prioritize the actions that decreases risk of the failures. Next, we are going to discuss about the various procedures or steps which is involved in the FMEA analysis. First important step is to determine the failure mode for each process input. For each failure mode, we want to determine its effects, and also we want to select the severity level for each effect in a 100:1000 ratio. And the next step which is involved in FMEA analysis is next we want to identify the potential cause of each failure mode, and also we need to select an occurrence level for each causes in the 1:10 ratio. The fourth step which is involved in the FMEA analysis is first we want to detect the failure mode. Second step is we want to know what are all the various causes of the failures, and the next step is we want to control the causes of the failure, and also we need to select the detection for each cause. Next step is to calculate the risk priority number, that means RPN. Next we want to develop the recommended action, assign responsible person and take actions. In order to know the risk priority number, in order to calculate the risk priority number, we first need to multiply the severity level into occurrence level into detection level. The severity level can be of the anything from the range from 100 to 1000. If the severity level is 1000, that means it is very maximum. If the severity level is 75, that means it is okay. It is the importance of an effect on customer requirements. If the severity level is 1, if we give a ratings based upon the severity level of 1:10, if it is 1, it is not severe. If the rating is 10 for the particular product, it is very severe. Next, we need to determine the occurrence level, that means O, frequency with which a given cause occurs and creates failure modes. For example, within the 1 week, the particular product fails again and again, that means the severity level is more for the particular type of the product. If the severity level is 1, it is not likely to happen within the 1 month. Or else if the severity level, if we give a mark or ratings 10, it means the repair rate or failure rate of the particular product is more when compared to that of the other type of products. Next one is the detection level D. The ability of the current control scheme to detect or prevent the given causes. If the rating is 1, it is easy to detect, or if the rating is 10, it is not easy to detect the particular type of the product. We are going to discuss about the case study for drill bling hole using the FMEA analysis. This is the FMEA chart. First one is our major aim is to know about the drill blind hole, and then we want to determine the failure mode of the particular product or particular process. First failure mode, it can be of hole, it can be deep. Now next failure can be of hole, not deep enough. Next we want to determine about the potential effect of the failure. It can be break through bottom of the plate, or for this particular type of failure, the potential effect can be of incomplete thread form. Next we want to give the severity level mark, that means ratings for the particular type of the failure mode. Here they are given 7 for if the hole is too deep, and then they are given 5 the hole not deep enough. Next we need to determine about the potential causes of the failure. If the hole is too deep, the reason can be of improper machine setup. Likewise, if the hole is not deep enough, the main reason can be of improper machine setup. Next, we need to determine the occurrence level of 1:10. And the next step which is involved in the FMEA analysis is we need to determine how we can control the particular type of the failure mode. For that, in this case, we need to instruct the operator or trainer to follow the instructions. Then we need to detect the failure level, and also we need to calculate the RPN value. To determine the RPN value, we need to multiply severity value into occurrence value into detection value. In this case, 7 into 7 into 3, the value is 63. In the case of failure hole not deep enough, 5 into 3 into 3, the value is 45. If the RPN value is more, first we need to take the particular type of the failure mode, and we need to correct the particular type of action. This is one of the case study in case of drill blind hole using FMEA analysis. Thank you.